Good afternoon, viewers, and welcome to my channel Flex Master. Today we are studying the same chapter like yesterday, like previous chapter, chapter number 24 for flexible packaging. And here we will start flexible packaging, chapter number 25, the continuation of potential markets, flexible packaging for bread, biscuits, and cakes. For the bread, biscuit, and cake sector, flexible packaging solution can be tailored to suit the varied requirements. So, keeping biscuits crisp and fresh, cakes moist, and bread soft and duffy. This is achieved with a single and multi-material packs, bags, and wrapping films, barrier films, and laminates are used to prevent both the loss and absorption of moisture to protect and maintain product quality, preserve freshness, as well as extend the shelf life of a wide selection of baked goods. Like here, the lamination available combination CPP, cast polypropylene, bi-oriented polypropylene, polyethylene, BOPP plus adhesive plus BOPP, 3 layers, BOPP plus adhesive plus metallized BOPP, PET plus adhesive and metallized BOPP. These are the combination of the raw material, the substrate used for packing bread, biscuits and cakes. The next one is for snacks and chips packing. Flexographic printing techniques to deliver a distinct advantage on the store shelf and provide maximum shelf appeal to the consumers. The laminates in roll stock as well as various styles of pre-made pouches. That is for potato chips, extruded products, ready to eat, popcorn, etc. etc. These are the combination of the laminated material. Now here we come into printing methods in flexible packaging. In flexible packaging, there are first printing method in the olden days use are rotogravure is a primarily a long run, high speed, high quality printing method like engraving. Gravure is a form of intaglio printing that produce fine detailed images. It works with the well for CMYK, cyan, magenta, yellow and black printing where each color of ink is applied by its own cylinder and with drying steps in between. Like flexography, gravure printing predominates in the high volume printing of packaging, wallpaper and gift wrap. Although less common, it also works for printing magazine, greeting cards and high volume advertising pieces. How gravure works in gravure printing, an image is acid etched on the surface of a metal cylinder, one cylinder for each color in a pattern of cells. The cells are increased into the cylinder. Unlike relief printing or letterpress, where the printing image is raised, or like offset printing, in which the image is level with the plate, the cylinder is etched with cells of different depths. These cells hold the inks that is transferred to the substrate. The dimension of the cells must be precise because the deeper cells produce more intensive color than shallow cells. Here is a gravure cylinder, here is the impression cylinder, this is the substrate, paper or plastic film, printed side of paper, this is ink tray and Dr. blade which will wipe the excessive ink from the gravure cylinder. Rotogravure printing machines is used in flexible packaging, manufacturing and printing process including polyester, nylon, BOPP, aluminum foil, polypropylene, low and high density polyethylene, etc. The most advanced handled double printing facility faced with high speed hot air dryers. There are also specialized machines for printing polyethylene bag, polypropylene and cellophane and roll paper. It is a kind of printing equipment ideal for producing paper food bags and grocery bags. Publication gravure presses operate at 45 feet 14 meters per second and above, and with paper rolls widths greater than 110 feet 3 meter, allowing an 8 units to print approximately 7 million pages 4 color per hour. The vast majority of gravure press print on rolls, also known as webs of paper or other substrate, rather than sheets. Rotogravure presses are the fastest and widest press in operation, printing for narrow web labels to 12 feet 3.66 meter narrow labels, 3.66 meter wide vinyl floor rolls. For maximum efficiency, rotogravure press operate at high speed, producing wide, large diameter rolls. These are cut down to roll size finished on a cylinder or rewind. The printing methods in flexible packaging and the advantages of rotogravure printing. It will highlight here. Rotogravure is a high-speed, high-volume printing press process capable of printing continuous tone images. Number two, as a direct printing process, rotogravure results in better ink arrangement and more consistent quality. Print times are extremely fast, and with modern presses capable of producing up to 14 meters of film per second. Rotogravure printing uses fast drying solvent based inks to speed up the printing process. As the process is mostly automated, labor costs are lower. Rotogravure cylinders are very durable. They can be used for multiple print runs. Now the disadvantage, that is initially cylinder setup cost can be very high. Rotogravure printing is not a price competitive as other printing method, especially for shorter runs. Now come to the flexographic printing. We have discussed in our beginning of this chapter for flexographic printing. At present, most flexible packaging worldwide is printed using the flexographic printing method. Flexographic, or simply flexo, is a rapidly growing package printing process. Is taking market share from gravure. Basic gravure process technology is also used for corrugated boxes, flexible retail and shopping bags, food service bags and snacks, milk and beverage cartons, pressure sensitive adhesive label. Flexographic printing for packaging provided the ability to reproduce basic text information and large single color areas. The process gained widespread application for transparent flexible packaging, initially cellophane and eventually plastic film. Its inexpensive photopolymer printing plates were well suited for smaller production runs, 100,000 impression and less. The minimal time and expense to produce or modify plates are also favored regional product brands and promotional graphics for short-term use with larger brands. Forces that lead to innovation in gravure process and equipment also stimulated flexo changes that dramatically increased quality and reproducibility. The changes increased the cost of flexo printing plates, but still maintained an economic advantage over gravure for all but very large press runs. Flexo printing also provides the flexibility to use various types of inks. UV inks are cured with ultraviolet light rather than standard drying methods used for water or solvent-based inks, allowing them to dry faster. UV ink is perfect for any tags or labels that will be left out in the sun. As the UV light from the sun cures the ink further, various clear varnishes or metallic inks can also be applied to customize the final printed product. The flexographic printing process. As the roll of substrate unwinds, the sheet passes through a series of printing stations. An analog roll made from the steel or aluminum with a surface etched by shallow well dipped into an ink fountain. The analog roll is wiped with a clean with a doctor blade to leave an uneven consistent layer of ink. Then the ink is applied to the plate image. The substrate is then passed pressed against the plate with an impression cylinder, applying appropriate pressure to transfer the image into the surface. A series of UV lamp or IR dryers dry the prior to next process. Advantages of flexographic printing: runs at extremely high speed up to 2000 feet per minute and is ideally suited for long printing runs as well. Prints on a wide variety of substrate materials, short setup times with a minimum waste, guarantee high quality output. Eliminates the need of additional work and cost. Printing, varnishing, laminating and die cutting can be done in single pass, most specifically while you are printing the pressure sensitive labels. Disadvantage of flexographic printing: the price of flexo printing plates is higher than the other types of plates, but the last for the millions of impressions when cared for properly. Because most revisions will require a new plate, changes can be time consuming to make. This is the how the rotogravure press looks like. The primary elements of gravure press: engraved gravure cylinder still represent the limiting time and cost factors for gravure printed flexible packaging. Equipment for process is expensive, its footprint is large, and staffing requirements, both in numbers and skill, relatively high. Some of these limitations are decreased with new basic design themes: interchangeable print stations, trolleys, advanced digital monitoring and control. But such features tend to increase the purchase or price of new equipment. Even so, productivity and efficiency gains from new equipment often makes replacing old press with new ones a good investment. These gains can be so considerable that one new press can replace two or three older ones. The low operating cost combined with higher productivity provide the positive return on investment. Now come to the ink viscosity. Now we are going little bit details in terms of technical ink viscosity. Sorry. In addition to basic web control components, an ink circulation system is critical for maintaining print consistency. This system includes subsystems to monitor and control ink viscosity. Viscosity control for solvent inks involves replacing the organic solvent that has evaporated from the ink circulating system with makeup solvent. Manual techniques for measuring ink's viscosity involve an indirect assessment of viscosity using a small 1.5 ounce 44 ml stainless steel Zan cup with a hole in its center and a long handle attached to the sides. The cup is dipped in the ink and the time required for it to empty, that is efflux time, noted. Zan cups are designed number 1 through number 5 based on the diameter of the bottom hole. Larger holes for more viscous liquids. The size of the cup is chosen to ensure sufficient efflux time for a precise measurement using at least 1015 seconds, 10 to 15 seconds, sorry. Packaging gravure inks are considered press ready at about 2030 seconds. Number 2 Zan cup, 2156 centi chokes 5 mm, 2 per second. Automated ink viscosity measurement typically uses the falling body technique. This consists of a tube containing the ink and a smooth ball. The ball is placed in the fluid and the time that it takes to fall the length of the tube noted. In both manual and automated cases, the assumption involved is that viscosity is too great as a result of evaporation of volatiles. The response to high viscosity is to dilute the ink. If viscosity is in fact low, solids, pigment and or vehicle must be increased. If the original ink solvent is a blend, example ethyl alcohol and ethyl acetate, the replacement or makeup solvent will contain more of the solvents with the fastest evaporation rate. in order to keep the composite ink formulation as close to original blend as possible. Water-based inks can evaporate ammonia and experience viscosity changes. Monitoring the pH value of such inks and adjusting it with concentrated ammonia solution control its viscosity. Energy cured inks have essentially no volatile components, so they have stable viscosity on press. So we will finish this chapter number 25 and we will continue with our next chapter in our next video. So friends, we have finished the chapter number 25 for flexible packaging subject, and we will continue our next video, the next chapter, in the same subject. So until then, please take care of yourself and kindly share and comment and like and subscribe our channel and spread over those your friends and relatives, those who are interested to learn. Thank you very much.